Hey guys, welcome to my lightning talk, Amazon Rekognition, the proven machine learning tool. My name is Siddhartha Akula, so let's get started. Um, I'll call this lightning talk Amazon Rekognition tool as the proven tool because I myself proved it, because I worked on it extensively and I've seen the big clients using it as well. I've researched enough to say that it's a proven machine learning tool and the market says so. So let's go through the overview. So let's get started with what is Amazon Rekognition and why to use Amazon Rekognition, and then we'll go through a background of how computer reads the pictures and how does reading pictures by computers help the Amazon Rekognition, and then we'll go through the sample flow of Amazon Rekognition APIs to understand how we can use the Amazon Rekognition APIs in our applications. And then we'll go through few use cases where Amazon Rekognition APIs can be used. And then we'll go through the high level insights of the code, how to integrate with Amazon Rekognition, how I have integrated with Amazon Rekognition. And you can ask me questions right then when I show the code. And then I'll finally demonstrate how Amazon Rekognition APIs hosted on AWS Cloud can be used in our apps. It's a visual concept at the end. So what is Amazon Rekognition? Amazon Rekognition, uh, to say it in simple terms, Amazon Rekognition makes easy to add image and video analysis to our applications, like life simple. So if we know that all the applications nowadays need some amount of multimedia to process. For example, social media apps, the like applications that takes the images, apps that takes the videos and text notes, they all need some kind of multimedia. And since they take vast amounts of data in billions of megabytes or gigabytes, they needs to be processed in some way. For example, when we start a startup, um, if that takes some kind of certificate for the verification of the user or client, we need to make sure they are uploading a proper images, not any improper images. So we need to analyze those images. For that, we need to have uh, some kind of application that does the image processing or video processing. So that's what Amazon Rekognition does. It is a machine learning and deep learning based technology developed by Amazon computer vision scientists for their own processing. And they have made it a third party app within the Amazon Web Services cloud. So to say simply what is machine learning and what is deep learning, machine learning is study of computer algorithms that improve automatically through experience as well as reading tons of data. And deep learning is subset of machine learning, which has artificial neural networks that learn from vast amount of data. So all the algorithms on which the Amazon Rekognition APIs works on machine learning or deep learning. Uh, so why to use the Amazon Rekognition APIs? We can say that there are apps that are available in the market that does the same functionality like Amazon Rekognition APIs does. But there are three factors why we should choose the Amazon Rekognition. Amazon Rekognition is cheaper app. The security is really reliable because it's the app within the Amazon Web Services and it's easy to integrate. Three factors are easy enough for me, at least, to consider that Amazon Rekognition can be used as an alternative for whatever is available in the market. Let's go. So before going further into Amazon Rekognition background, I just want to give some context where this all started. So this is the first image ever to be scanned by someone called Russell. He's a computer engineer working in National Institute of Standards and Technology. So he scanned this image, which is of 176 by 176 pixels, which is around 30,000 pixels. And nowadays we scan the images that are like millions of pixels available. So we have come a long way, starting from what we have started and what we are doing now. So for all this to be working, again, so we see the world differently and computers see the world differently. We just see an image as a shade of something or whatever is written or anything, whereas machines see them in binary representation in the form of binary codes and how they are pixelated, what is the border in between those pixels, the colors, the shades, and the spatial relations between those pixels. By comparing and identifying all these pixels, a image is put together by machines and they are read by machines for processing. Uh, so before going into in-depth code level insights, let's start with the user flows. And here I have put together in the diagram where we can see Amazon S3, AWS Lambda, and Amazon Rekognition. For people who haven't worked on Amazon Web Services, this might be alien, but to simply put it, you can consider this as an input source. This is as an application, and Amazon Rekognition as an external APIs that are being used by our application. For people who have worked on AWS, I don't have to say this, Amazon S3 works as the database for us, and AWS Lambda is a serverless application on which we can host our applications. And Amazon Rekognition acts as an external API, which does the process of detecting faces in each frame, moderating the content, and comparison of text inside the images. So some of the use cases where Amazon Rekognition services can be used are content moderation, object and scene detection, facial analysis, celebrity recognition, text recognition, and face comparison. I can talk about individual use cases when I show the demonstration of how Amazon Web Services recognition can be used. But to put it simply, these are the major use cases where Amazon Rekognition is extensively being used nowadays. Let me go through the code to show how I have integrated and what I have written. So I have built a simple application where Amazon Rekognition APIs are used. So for easy understanding, this can be said in 3 ways. Step 1 is to integrate with Amazon Rekognition, which can be initialized by providing the data like region, access code, secret code that I have given the config repo or configuration. And step 2 is to parse the parameters that we need to pass for the Amazon Rekognition AR. So the parameters that I'm parsing here can be given either as an input through input link, which can be given as an input link through Postman while you're testing, or the second way is by giving the link of S3 hosted image, or the third way is giving the local location of your app in your local machine. And the third one is that we take the initialized object of the Amazon Rekognition and we use various functionalities available in the Amazon Rekognition package, and we pass the param and we get some form of input. So when I say some output, when I say some form of output, we get as a JSON object, we can read that object and say how we can use that for our functionality in our applications. To go back to user flow, this is what I've been talking about. So we pass an input for our application, which reads the Amazon Rekognition APIs and gives the output in some way of JSON, which can be read again the other way. Now let's go through the demonstration of Amazon Web Service hosted app. So these are the use cases that I was talking about: object in scene detection, image moderation, facial analysis. Let's take one of the use case that we've been talking about. Since we are talking so much about the machine learning and deep learning concepts, let's take a simple image and see how that image can be processed. So here it's a clean image. It doesn't need any moderation. People are having fun here and they're having party and let me show you, this is a past use case. Let me show you a negative use case for that. So this is the famous Keanu Reeves John Wick movie picture, which is having some violent content, the infamous pencil murder. So we see that there is so much of violence here. There is some blood, and of course, Keanu Reeves is so violent. Yeah, we see the two factors. One is violence and graphic violence here, which says with confidence, 74% violence and 74% graphic violence. So we can write a logic like, if violence is more than this amount of percentage, we don't accept the image in our applications. So when we build an applications, we put a simple filter where Amazon Rekognition APIs can be used. And that what that filter does is it just filter out the violent content. The same can be done for any kind of glitch. Let me show one more negative case. Here we see the Punisher punishing a lot of people. And here again, we see 99% violence and graphic violence. These are some negative cases where the image moderation can be used. And facial analysis is one of the use case where a image can be read and say what is all in that picture. It says, looks like a face, appears to be female, age range, smiling, she's happy, and of course she's wearing glasses. So these are all like millions of images are fed into Amazon Rekognition APIs and they're trained already. That's why they're so perfect at this point. Celebrity recognition. And of course, Jeff Bezos. Let's do our own use case of uploading a picture. You might be asking why Keanu Reeves? Keanu Reeves, I'm a big fan. So here we see that with confidence of 99%, it says this is a Keanu Reeves picture. This can be used in a case where we have an application and we want to have profile pictures for individual user. And some people might be uploading the fake pictures of somebody else or some celebrities, at least in this case. We don't want those fake use cases. So having a filter of this type can filter out at least some part of unwanted pictures.
Sid, I'm upset you didn't use me as a celebrity.
Yeah, I thought of asking, is there any celebrity here? And then I remembered Jen, and I realized I don't have Jen picture here. Yeah, if I have your picture, I would have uploaded with pleasure. Yeah, and yeah, we have one more use case that is face comparison. This can be used in multiple use cases in the social media context. Here we see text content. It read, it's Monday, but keep smiling. The same is said in the results. So I haven't talked about like how we get the JSON response from the API for people who are technical here. When I said confidence, this is the object that we get. We check the specific field inside that object, confidence, which is a common protocol or common contract when we interact with Amazon Rekognition APIs. So based on this factor, we do all the logic. One more here. Here, the New York City police might be using some similar algorithm like this, which they are using for giving us tickets. I got ticket to my car once in city. So they just take the picture, they read millions of pictures just like this. They upload all the pictures and all the data is extracted. And there is a new offering in Amazon Web Services where the PPE kit, facial, safety gloves or face masks, whether it's present or not, that's what is said as part of this one, is a new offering. I haven't used it yet. Yeah, these are various types of use cases that can be used through Amazon Rekognition service. And I've shown how it can be written the easiest way, the 3-step process. And coming to the pricing, this is one of the cheapest one for at least the first year. It accepts like 5,000 images for free to process. So 5,000 images can be processed in any of the use cases. And coming to videos, it can, storing of the individual people's faces, this can be done through Amazon Web Services, Amazon Rekognition APIs as well. 1,000 faces can be stored. On top of that, the pricing has changed and they're still updating that. At this point, it's cheaper. And the videos analysis can also be done, but it's an extensive topic again. I haven't worked on the video processing. Most of my work is based on image analysis, so I'm very much aware of those two. Oops, sorry. So in conclusion, integrating as I said, the 3 main factors why to use the Amazon Rekognition is it's easy to integrate. The security factor is overridden because It's part of Amazon Web Services offering. And so the security is really reliable, and the prices are very cheap, at least for startups in the initial phase. Once you start 2 years or 3 years, the pricing changes. So the first few years, it is really cheap. These are all the sources. You can fork my repo from my GitHub, and these are some of the sources we have.